Hey guys, today's video is meant to explain the concept of a variable's value and its memory address. Now, a lot of you might be thinking this is really basic stuff. And if you already know it, feel free to skip to the end. But if you don't, these are going to be your fundamentals, your building blocks towards various advanced data structures like linked lists, like graphs, like trees, and even arrays are nothing but pointers, which is why you're going to have to know this concept. So before we start off, let me draw a few analogies. So first, let's assume that you live in an apartment. Let's say the apartment's number is 101 Ghanta Bell apartment. All right. Say a postman comes to your house. He wants to deliver something to you. There has to be only 101 in your apartment. Otherwise, it doesn't make much sense, right? He comes to your house. You say there's one more 101 right across. He goes there, the diligent postman. That guy says, no, you have to go down the hall and take a right. Then the postman will start getting psyched out. Now, what type of apartment is this? An address is used to uniquely identify a location. That's going to be where the variable is stored. What we don't see as programmers, what happens behind the scenes is that whenever you declare a variable, say int a equals 5, the computer actually assigns a location to it as well. Now let's have a look at our screens right here. Int a equals 5 and we're printing a. Now there's nothing special. It's as simple a program as our traditional hello world ones. The output is going to be 5. But what's hidden behind the scenes, behind closed doors, is its memory value. So we can access its memory value using ampersand a in C programming. You can print it using %p. So if we run this, here we can see its memory value. Now don't get scared by this. If we just copy it, oops, copy, not paste. Yeah. And we go to a hexadecimal converter, we can see it's actually a normal decimal number, maybe a really big one, but a decimal number nonetheless. And this is binary equivalent, which is massive. That's why we convert it into hex instead. The string becomes much shorter. Now let's do another thing right here. Let's declare an int b. We say b equals a. Now if we print a and we print b, we print a and b, what do you think will happen? Nothing out of the ordinary, nothing too special. We get 5 and 5. To draw another analogy, let's say you're in 101 and your friend also wants to buy a house in the same apartment complex. He buys number 202. So he comes to your house before buying and he really likes the decor, he really likes the interiors. So he says, bro, whatever is there in your house, I'm going to copy and put in my house. My house is going to look exactly the same as your house. So that's what he does. Your house and his house are now carbon copies, but you have two different addresses. Now, let's say your friend adds something to his house. He puts a new TV in, he puts a new lava lamp in, he changes the wall color. Now his house changes, the contents of his house, the value of his house changes, but your house remains the same because there are two different addresses. Which is why your house or A is still 5, but the new location B is now 7. Now you're wondering why I'm telling you all this. I'll tell you why, because now it becomes a lot easier to explain the concept of pointers by drawing parallels. Now, suppose this is an integer pointer instead, all right? So in C, you declare pointers with star, and remember, you assign addresses with ampersand. When we do this, what happens is your friend isn't buying a new house, he's coming in and moving into your house. So for simplicity's sake, let's say the address of A is 101. Now, your friend has also come into your house and he's changed some things. Let's say he's drawn a portrait of his favorite childhood crush, Katrina Kaif, in front of the main door. Whenever you enter the house, you're also going to see it because his house is your house. Any change he does in his house gets reflected in your house. So what this statement says is, go to the location with value 101. We're assuming A's address is 101 and increment that value by 2. Now what do you think will happen when we print A and let's print star B. Star B is used to denote the contents at B. Now we're going to get 7, 7. A has also been updated. That's because B has gone to the location and it's updated the value. And A's location and B's location are the same. In order to make it more intuitive, let's try adding a function here. Let's call it int add, all right? Let's just say void add. And let's pass int a as a parameter. We say a equals a plus, let's say 5. Let's remove this b right here. And we pass a into the function. Let's add a print statement here. Say printf the result of add function is %t. Let's just say the add function. Grammar Nazis that we are, and comma a. And here let's say the result of the main function is. Let's run the code. So the result of the add function is 10, but the main function's a value doesn't change. This is how we use functions most of the times, and this is called calling by value. So what happens is this a and this a are not the same. These are two different a's, and this a's value gets copied into that a. But whatever change happens here is independent of this. So this value won't get affected by this change. This concept gets flipped on its head when we're talking about pointers. Now, if we pass the address, it's called calling by reference. So let's say int star a here. Now, if we say star a is star a plus 5, we print star a here and we print a here, you're going to see that both a's have changed. This concept is very similar to the example we just discussed. We've passed the address here. This line says, get the value at location 101 and increase it by 5. But a is also at location 101. So a's value also gets updated, which is why both the print statements say 10. In other words, if we're changing a value at a pointer's location in a program, that change gets reflected everywhere else, regardless of whether it's in the main function, the add function, or any other function. That change is going to be seen throughout the program. Guys, this was a quick explainer video about a variable's value, its address, pointers, and how they work. I hope you liked it. If you did, you're going to see 3 buttons on your screen. You know what they are. Make sure to click them and leave your comments down below. I'll see you all next time.